Good morning, my dear students. Now in this video clip, I want to discuss about the very important derivation, that is the radius of stationary orbit of an electron in hydrogen atom. Particularly what you say, that is in nth orbit. Already you know that postulates. What are the three important postulates for the Niels Bohr atom model postulates? Now first one is the electrons are revolving around the nucleus in the orbit. They have definite state of energy. These orbits are called stationary orbit. Second one, when a electron move around the nucleus in an orbit, this angular momentum is equal to integral multiple of h upon 2 pi. I heard it. Integral multiple of n h upon 2 pi. Andre L is equal to n h upon 2 pi. Or in other words, mvr is equal to n h upon 2 pi. This is second postulate. This is also known as Bohr quantization rule. Then third postulate is when electron transition takes place from higher energy state orbit to the lower energy state orbit. Now it emits the radiation, radiant energy or photon. That energy is equal to difference in the higher energy state and the lower energy state of the orbit in the atom. Hege ಹೇಳ್ತಾನೆ ಅವಾಗ radiant energy, emitted energy E is equal to hν is equal to E2 minus E1. You have to take care. E2 is the energy of the higher energy state, E1 is the energy of the lower energy state, or we said to be orbit. Even orbit ನಾವು ಏನು ಹೇಳ್ತೀವಿ stationary orbit. Why you say stationary orbit? Because when electrons are move around the nucleus in a particular orbit, they do not radiate any energy. ಯಾವ ಎನರ್ಜಿನೂ ರೇಡಿಯೇಟ್ ಮಾಡಲ್ಲ ಯಾವಾಗ ಆರ್ಬಿಟ್ನಾಗ ಸುತ್ತ ಹಾಕುವಾಗ. When that electron emits the energy, atom emits the energy, only when the electron is transition takes place from higher energy state to the lower energy state. ಇಷ್ಟು ಪಾಯಿಂಟ್ಸ್ ನಾವೇನು ಮಾಡಿದ್ವಿ ಇದು ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋ ಕ್ಲಿಪ್ ನೊಳಗೆ ಹೇಳಿದ್ವಿ. ಈಗ ವಾಟ್ ಇಸ್ ದ ಯು obtain the expression for the radius of the electron in the nth orbit. ಅದನ್ನು ನಾವು ಡಿರೈವ್ ಮಾಡಿ. Now see here, what is the nucleus? Is the orbit. Now this orbit is said to be stationary orbit. ಹೀಗೆ ಸಾಕಷ್ಟು ಇರ್ತವ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್, ಬೇರೆ ಬೇರೆ ಎನರ್ಜಿ ಸ್ಟೇಟ್ಸ್ ಅಂದ್ರೆ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್. Now ZE, now this is the nucleus, and plus ZE is the charge of the nucleus. Then electron E minus of mass m, velocity v and radius r. Here m is the mass of the electron and E minus you said to be E charge of the electron. R is the radius of the stationary orbit. ZE is the charge of the nucleus. Z is you said to be proton number, or you said to be atomic number. Proton number ಅಂತ ಹೇಳ್ತೀವಿ ಅಥವಾ atomic number ಅಂತ ಹೇಳ್ತೀವಿ. And very important concept by the Rutherford. What is that one by the Rutherford? ಅಲ್ಲೇ Rutherford ನಿಂದ ಏನು ಬರ್ತದೆ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್? when electron move around the nucleus, now the necessary centripetal force of the electron, it is provided by that is the electrostatic force of attraction between nucleus and the electron. Therefore the electrostatic force is equal to centripetal force. Centripetal force is equal to, or listen to me, centripetal force is equal to, that is the electrostatic force. What is the centripetal force? mv square by r. What is the electrostatic force? 1 by 4 pi epsilon naught charge of the nucleus into charge of the electron divided by square of the distance, r square. Now you take the mv square, r, 1 r get cancels here, remaining r only. 1 upon 4 pi epsilon naught ZE square divided by r. Now you take the r in this side, mv square r is equal to 1 by 4 pi epsilon naught into ZE square. Just hold it. Andre ZE square divided by 4 pi epsilon naught. Now this is equation number 1. Now by Bohr quantization rule, this is the second postulate. Angular momentum mvr is equal to integral multiple of h upon 2 pi. Yes. ಅವಾಗ ಫಿ ಅಷ್ಟೇ ಏನಾಗ್ತದೆ, ಫಿ ಅಷ್ಟೇ ತಗೊಳ್ತಾನೆ ನಾನು, ಎನ್ ಎಚ್ ಅಪಾನ್ 2 pi m into r. Now you substitute this phi in this equation. M phi square n h upon 2 pi mr whole square into r z is square divided by 4 pi epsilon naught. R square ಮಾಡಬೇಡಿ, m into n square h square 4 2 raised to 2 4 pi square m square r square into r z is square divided by 4 pi epsilon naught. Now here one r get cancels here, on the remaining r with, then as it is you have to write here one m get cancels here, as it is z is square divided by 4 pi epsilon naught. M get cancels, what you got finally, r is equal to, r you have to take this side, 4 pi epsilon naught n square square. ಸೊ ಇನ್ನೊಂದು ಸ್ಟೆಪ್ ಬರೀಬೇಕಾದ್ರೆ ಏನಂತಂದ್ರೆ z is square divided by 4 pi epsilon naught is equal to n square h square divided by 4 pi square r. R you have to take this side. Again 4 pi epsilon naught n square h square divided by, ಈ ಕಡೆ ಬಂತು, divided by 4 pi square m ಇಲ್ಲಿ ಉಳಿತು, ಒಂದು m ಉಳಿತು, m here, yes 4 pi square z ಈ ಕಡೆ ಬಂತು, r ಈ ಕಡೆ ಬಂತು, r ಈ ಸೈಡ್ ತಗೊಳ್ರಿ, r ಇದು 4 pi epsilon naught n square h square divided by r ಈ ಕಡೆ ಬಂತು, ಇದು 4 pi square m ಅಲ್ಲೇ ಓಡಿಸೋಣ, z square m z square. This expression. Now 4 get cancels, 1 pi get cancel, remaining epsilon naught n square h square divided by m pi z square. Z is equal to 1 for h item. At that time you have to r you take epsilon naught n square h square divided by m pi e square. This is expression for the radius of the nth orbit of an electron for any atom. Now this expression and this expression, okay, same, similar. It is the equation for the radius of the orbit of an electron in nth orbit of hydrogen atom. This is for any atom, but this is for particularly what you say, that is hydrogen atom. Z equal to ಯಾವಾಗ ಒಂದು ತಗೊಂಡ್ವಿ, that indicate that is you said to be hydrogen atom. Now we discuss this few points according to this expression or this one. Now this term is completely constant here. Epsilon naught 8.854 into 10 to the power of minus 2, Planck constant. Okay, 6.25 into 10 to the power of minus 34. Mass of the electron 9.1 into 10 to the power of minus 31 kg. Pi 3.142. E charge of the electron 1.6 into 10 to the power of minus 19. Now you substitute all the things for n is equal to 1. R1 is equal to 0.529 into 10 to the power of minus 10 meter, or that is R1 is equal to 0.53 into 10 to the power of minus 10 meter, or is said to be 0.53 angstrom. This is said to be radius of the first orbit of an electron in hydrogen atom. This value is called Bohr radius. What is the meaning of Bohr radius? The radius of the first orbit of an electron in the hydrogen atom is called Bohr radius. Its value is 0.53 angstrom. Thank you. Good morning, my dear students. In this video clip, I want to discuss about the orbital velocity of the electron in the nth orbit of the hydrogen atom. Now, already you know that important three postulates of the Niels Bohr atom model, and in previous video clip you obtained the expression for that is a radius of the electron in the nth orbit of the hydrogen atom and nth orbit of any atom. And in this video clip I want to discuss about the expression for or equation for velocity of the electron in the nth orbit of the hydrogen atom and time period and frequency. Now again, using the that is the Bohr's postulate and Rutherford concept, you have to obtain the equation of the orbital velocity of the electron in the hydrogen atom. Now see here, it is the nucleus of an atom of charge plus Ze. Ze is the charge of the nucleus. Then m is mass of the electron and E is the charge of the electron. P is the velocity of the electron which it is moving in nth orbit. Then Rn or said to be R is the radius of the nth orbit of hydrogen atom. Now according to Rutherford and Bohr postulate, now this is the centripetal force is equal to electrostatic force of the attraction between nucleus and the electron. It is provided by the centripetal force provided by the electrostatic force. Here centripetal force is mv square by r. What is m? Mass of the electron. P velocity of the electron. And r radius of the orbit of the electron. 1 by 4 pi epsilon q into q, Z into E divided by r square. Z into E is Z square. Z into E is Z square. Now it is a 4 pi epsilon net. This is r. One r get cancels here. This r is cancelled here. Then you got r here. R you take here. mv square r is equal to Z square divided by 4 pi epsilon. Same type radius now expression derive ಮಾಡಬೇಕಾದಾಗ ತಗೊಂಡಿದ್ದೇವೆ. Yes, by Bohr quantization rule, second postulate, Bohr's postulate, the angular momentum is equal to integral multiple of h upon 2 pi. mvr is equal to nh upon 2 pi. It means the angular momentum of an electron in the orbit is equal to integral multiple of h upon 2 pi. And already you know this one, n is equal to 1, 2, 3 and so on. Nth orbit, first, second, third orbit, 4 like this. Then divide these two. mv square. ಅಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ, v ತಗೊಂಡು v ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ವಿ. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದೇವೆ, ಡಿವೈಡ್ ಮಾಡ್ತೇವೆ. ಡಿವೈಡ್ ಇಕ್ವೇಶನ್ ನಂಬರ್ 1 by ಇಕ್ವೇಶನ್ ನಂಬರ್ 2 ಡಿವೈಡ್ ಮಾಡಿದ್ವಿ. ನಾವು mv square r divided by mv r. Here Z square 4 pi epsilon naught divided by nh upon 2 pi. ಇಲ್ಲಿ m ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು, r ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು, ಇಲ್ಲೆಲ್ಲ ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು, ಒಂದು v ನು ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು. ರಿಮೈನಿಂಗ್ ಇಟ್ ಇಸ್ v only. Then Z square upon 4 pi epsilon naught 2 pi reciprocal ತಗೊಳ್ಳಿ, 2 pi upon nh. ಇಲ್ಲಿ ಏನಾಯ್ತು, pi pi ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು. Then remain Z square. ಇಲ್ಲಿ 2 1s 2 2s 2 epsilon naught nh. 1 by n into bracket Z square divided by 2 epsilon naught h. This is the equation for velocity of the electron in nth orbit of the any atom. For hydrogen atom, Z is equal to 1. Now it becomes Z equal to 1, that is V is equal to E square upon 2 epsilon naught nh. Equation number 5. Now you substitute the value of charge of the electron, permittivity of the free space, now orbit number and Planck constant 6.625 into 10 to the power of minus 34 second. You got the answer is in the order of 10 raised to 6 meter per second. But it is depending upon that is the which atom you have to take here, which nucleus of the atom you have to take. Other ಮೇಲೆ depend. Why? Because it's Z and N. Okay, Z ಮೇಲೆ depend with N ಮೇಲೆ depend with hydrogen atom ತಗೊಂಡಿದ್ದೀವಿ ನೋಡಿ. It is in the order of 10 raised to 6 meter per second. Now you see here, it is here V proportional to Z here. In remaining all the constants, V proportional to Z. V is proportional to, that is said to be Z by N. Hydrogen atom ತಗೊಂಡ್ರೆ V inversely proportional to N. ಅಂದ್ರೆ ಏನಾದ್ರು ಹೈಯರ್ ಆರ್ಬಿಟ್ ಹೋದಂಗೆ ಏನಾಗುತ್ತೆ, ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಕಡಿಮೆ ಆಕತ್ತ ಹೋಗ್ತದೆ. ಇನ್ನರ್ ಆರ್ಬಿಟ್ ಬಂದಾಗ ಫಾಸ್ಟ್ ಆಗಿ ರೊಟೇಟ್ ಆಕತಿ. ಒಂದು ಐಟಮ್ ಇಂದ ಇನ್ನೊಂದು ಐಟಮ್ಗೆ ಫಸ್ಟ್ ಆರ್ಬಿಟ್ ನಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ವೆಲಾಸಿಟಿ ಚೇಂಜ್ ಇರ್ತದೆ. ಹೈಡ್ರೋಜನ್ ಐಟಮ್, ಹೀಲಿಯಂ ಐಟಮ್, ಇದು ಫಸ್ಟ್ ಆರ್ಬಿಟ್, ಇದು ಫಸ್ಟ್ ಆರ್ಬಿಟ್, ವೆಲಾಸಿಟಿ ಎಲೆಕ್ಟ್ರಾನ್ ಫಸ್ಟ್ ಆರ್ಬಿಟ್ ನಾಗ ಇದ್ರೆ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಯಾಕೆ? ಆಟಮ್ ಡಿಫರೆಂಟ್, ನ್ಯೂಕ್ಲಿಯಸ್ ಇಸ್ ಡಿಫರೆಂಟ್. ಒಂದು ಹೈಡ್ರೋಜನ್ ಇನ್ನು ಹೀಲಿಯಂ ಚೇಂಜ್ ಇರುತ್ತೆ. ಓಕೆ, ಆಮೇಲೆ ಆರ್ಬಿಟ್ನಿಂದ ಹೈಯರ್ ಆರ್ಬಿಟ್ಗೆ ಹೋದಂಗೆ ಏನಾಗುತ್ತೆ, ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಹೋಗುತ್ತೆ. ಆ ಪಾಯಿಂಟ್ ಇಲ್ಲೇ ಹೇಳ್ಬೋದು. Then we come to the point time period. What is time period? Now the time taken by an electron to complete one revolution in its orbit is called time period. Once again I repeat, it is the time taken by an electron to complete one rotation or one revolution in its orbit is called time period of an electron in that orbit. Now what do you take here? Velocity is equal to distance divided by time. And t is equal to s by v. S it means total distance covered. Once the electron it complete one revolution, how much distance is covered? How much distance is covered? This is equal to circumference 2 pi r. And what is the time taken? Time period. T is time period. At the time period you take the time, instead of time you take time period. Definitely the distance covered is circumference. That is 2 pi r. 2 pi r divided by v. Yes, t is equal to 2 pi r divided by v. You substitute v here. Z is square 2 epsilon naught nh. Okay. Now rearrange this one. 2 pi r is 2 epsilon naught nh ಬಂತು z is square. Now t is equal to 4 pi epsilon naught r nh divided by z is square. ಇದನ್ನ z is equal to 1 ಬರೆದ್ರೆ this is for hydrogen atom. Then r substitute ಮಾಡಿದ್ರೆ r yesterday class ಹೇಳಿದೆ ನಾನು derivation epsilon naught n square h square divided by m pi z square. You substitute this one, pi get cancel. You got the equation time period is equal to 4 epsilon naught n cube h cube divided by m z square e raised to 4. Again ನಾನು z is equal to 1 ಬರೆದ್ರೆ time period is equal to 4 epsilon naught square n cube h cube divided by what you got here m e raised to 4. Time period. Then you come to the point frequency. Now next point is frequency. Frequency of the revolution. How much time period you got here? Time period is in the order of that is 10 to the power of minus 14 to 10 to the power of minus 15 second. It is in the order of 10 to minus 14 to 10 to the power of minus 15 second. Frequency. The number of revolutions completed by the electron in the orbit, this is called frequency. How many revolutions is completed in 1 second? The number of rotations or revolutions completed in 1 second in orbit is called frequency of the revolution of the electron. That frequency of the revolution is reciprocal of the time period. If it is reciprocal of the time period, that frequency you got m z square e raised to 4 divided by 4 epsilon naught square n cube h cube you got. m z square e raised to 4 epsilon naught square n cube h cube. ಇದನ್ನ reciprocal. Hydrogen atom for z is equal to 1. That is f is equal to r is said to be nu is equal to 4 epsilon naught square. This is z is equal to 1. m e raised to 4 divided by 4 epsilon naught square n cube h cube you got. This is the frequency of the revolution of an electron in the orbit of the hydrogen atom. This is for any atom. Now this frequency answer you got in the order of 10 raised to 14 hertz to 10 to the power of 15 hertz. It is in the order of like this, 10 raised to 14 to 10 to the power of 15 hertz. This is the frequency of revolution of the electron in a orbit, that is the nth orbit of an electron of the hydrogen atom. Now see here, previously in the Niels Bohr atom model there are 3 important postulates, 1 point, and you obtain the expression for what? Radius of the electron of the nth orbit of a hydrogen atom. Then today in this video clip you want to discuss about obtain the expression for velocity of the electron in nth orbit of the hydrogen atom, okay, or any atom, and you got the time period expression. and you got the frequency of the revolution of the electron in the nth orbit of the hydrogen atom. Next points next video continue. Thank you.